Hi all, we're in section 3.1, measure of central tendency, and this is a beginning of what we talk about in terms of statistics more. The first part was organizing the data, and now we're going to actually calculate some measurements. The first thing we want to do is define what a statistic is. So a statistic is a characteristic or measure obtained by using the data values from a sample. Now, a sample is taking a part of the data, not the whole data. So when we talk about from a sample, it's not grabbing all the data about that particular thing that you're measuring, but grabbing a small portion of that data. And you have to usually grab that small portion of that data in a random fashion. So you can't just go, oh, I want you, and you because your data points are close together. You have to just kind of mix everybody's name up in a bowl and grab the data, or there are different ways of sampling the data. The next thing that we want to talk about is a parameter. So this was about a statistic. A parameter is a characteristic or measure obtained by using all the data. Parameter is a characteristic or measure obtained by using all the data. All the data values from a specific population. So for example, if we were going to define the population as everyone in this math 132 summer 2020 class, then that population, we could take all the data from that population and make, let's say, talk about the mean height or the average height of everybody. Then that would be a parameter because we gathered all the heights of everybody in the class and figured out what the mean height was. If instead I said I wanted to determine the mean height of the class, but I'm only going to do it with a sample of 5 people, and we have more than 5 people in the class, then that would be a statistic. So a statistic comes from a sample, and a parameter comes from the whole population. Now, whenever possible, when we start calculating statistics and parameters, I don't want you to round your decimal value until the very end if possible. And then when we'll talk about what the right number of decimal places is for each value as we go along. So the first thing that we're going to talk about with central tendency is the mean value. And so this is an arithmetic average. And this is where you add up all the values in your sample or in your population, add up all values and divide the sum by the total number of data points added. Whoops. Now there is a statistic variable for the mean, and there's a parameter variable for the mean. So x bar is the statistic mean value. So that's the sample mean. And mu, which is this kind of, looks like a U. People think it looks like an M, but it's not. It's a U with a tail in front. This is a parameter value. And it's considered the population mean. And the way we calculate either one of these means is the notation. So if we let x, I'm going to say x sub 1, x sub 2, x sub 3, all the way up to x sub n be the data values. Of either our sample or our population, depending on which one you're working with. Then what we're doing is we're going x sub 1 plus x sub 2 plus x sub 3 plus, and we keep adding them all up. And then we're going to divide by the number of data points that we have. That's going to be our mean value. And you write this mathematically with this symbol. It's a summation sign. So it looks like a big E, but it's different than a big E. The summation of x sub I over n. And this is where I goes from 1 to n. This notation on the left is represented by this notation on the right. Those two things are equivalent. All right, so that's the mean value. And we're going to go through an example at the end after we cover mean, median, mode, and mid-range, and then we'll go through an example and do each one of those things. So that's what it means to be a mean. And now, median, here's our example down here. We'll go through that in a minute. A median is the midpoint of the data array. So what we mean is if you organize the data from smallest to largest, it's the middle point in that array. So organize from smallest to largest. This is median is the middle point of that array. Okay. So that's median. And again, like I said, we're going to do an example with each one of these things. And there's no statistical symbol for median. It's just median. Mode is the next central measurement. This is the value that occurs most often in the data set. Okay. And you can have one mode, two modes, multiple modes, or no modes. So you can have what's called a unimodal. That's just one value that occurs more often than any other. You can have a bimodal. That's where you have two values that occur the same amount, and that amount is more often than any others. You can have a multimodal, so it usually goes unimodal, bimodal, or multimodal. That's more than 2 modes. And then you can have no mode. That means no one value occurs more often than any other value. And then the last thing that we're going to talk about before we do an example is the mid-range. And the mid-range is this kind of really rough estimate of the center of the data. So the mid-range is what we figure is pretty rough estimate of the middle of the data. And it's the sum of the lowest value and the highest value divided by 2. Okay, so it's the average of the highest and the lowest value. All right, so we're going to stop there with those definitions, and in the next video we'll go over an example in a data set, how to find the mean, median, mode, and mid-range for that data set.